10 voters are asked to rank 3 brands of shoes, A, B, and C. The 10 voters turn in the following ballots showing their preference in order. We're supposed to write a voter profile for these ballots. Okay, so, we've done these before. It's like the other preference tables, it's just organized a little bit differently. So let's go ahead and reorganize it in the way we're accustomed to seeing it. So notice that this first person has written or ranked them in CBA. So how many others did that? So number 1 did 4, ranked CBA. Number 7 has CBA, and number 9. So 4 people ranked them C first, B second, and A third. All right, let's try the next one. So for BCA, so now I'm looking at BCA. Let's see, so 5 also did BCA, 8 ranked BCA, and 10 also ranked B, then C, then A. So first, second, and third place. So I have 4 voter preferences for BCA. And now looking at BAC, number 3 did BAC, and number 6 did BAC. So for BAC, I have 2 voters who turned in that preference. So again, this is, we're kind of used to seeing it written this way. And our table, we would have the voter, and then we would have first, second, third, first. So we would have first, second, and third place votes. And so again, we had CBA was one possibility, and 4 ranked them that way. We have BCA, and 4 ranked them in that order. And then lastly, we had BAC, and 2 voters ranked them in this order. So the other thing we can do, like I said, so this is kind of how we're used to seeing it. So rather than writing it as first, second, and third, we might go ahead and write it as C is greater than B is greater than A. And then we had 4 of those. And then we have 4 people who also ranked B greater than C greater than A. And then lastly, we have 2 voters who ranked them in the order of B greater than A greater than C. And so like I said, they all give the same information. It's just a matter of rewriting it. If there are n equals 8 candidates, how many different rankings of the candidates are there? So let me talk about a similar problem. If we were doing a pairwise comparison, since you mentioned this, pairwise comparison. We said, hey, I've got 8 candidates. How many different ways can I, pair them off together? We said, well, there was n times n minus 1 over 2 ways. So in this case, 8 times 7 over 2. So 56 over 2, which would be 28. So there'd be 28 different pairings. Okay, so now if I want to just know about all the rankings possible, so looking at just rankings, that's going to be n factorial, or in this case here, 8 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Plugging this in our calculator, we get 40,320. Okay. Another way you can kind of think about it is, the first candidate, there's 8 possibilities, and then for the next, position, there's 7 candidates left, then 6, then 5, then 4, counting all the way down to you've only got 1 spot left. So n factorial is the formula you would use for this.